Hi, welcome to our fourth lesson.
Hi, hello everyone. As Waha said, today is the fourth session of our Explore and Learn at Home with Twing. And one of the questions we received yesterday was about uploading videos to Twing. So I'll start by showing you how to do that. So first of all, I'm opening the app and here is the home page. And now I'll select one of the challenges. Let's say make a crazy Mobius strip, like the one we did before. So now here you can see the camera button. And once you open that, it now can shoot whatever you want. So all I have to do is press down this button. So let's see. So here I have this new video. So you can only take videos of up to 30 seconds. But after that, once you're done, you can just click pause, and then your video's up and live. So as well as this, you can also congratulate others on their videos. So let's say if I choose the challenge dance with soap bubble, I can always watch other videos and like their videos as well as leave a comment for them. So it should be easy, and I mean, we're still working with the user experience part of this app, but it's still working, and it will be way more easier and a lot fun once you try to do it again. So where were we?
So that's really nice. So let's look at our presentation and see what we have for you today.
So I guess there was a question we left unanswered yesterday. Yes. And let's check that out first.
Yeah, so this is the question that you asked yesterday, and let's learn what the answer is.
So, as you had guessed before, they met during a when Steve Jobs was working in a firm for a summer internship, and Steve Wozniak was an employee there. So they start working by beginning to design their own games, and then their partnership begins, and now we have Apple, and that's one of the products I'm using right now.
That's really interesting. So I think you also have some other questions that you'd like to ask today in our live stream.
You're right. So while we learned about Steve Jobs and Steve Wozniak, there is also another fun fact. So this one's about the octopus. So Wahad, do you know what color is the octopus blood?
So I know that my blood is red, and most other animals I know also have red blood. So I'll go with red.
In fact, octopus has blue blood. That's because of the hemocyanin it has in it. So hemocyanin is like hemoglobin, which gives us a color red in our blood. But in this case, it gives the color blue because it has copper atoms in it, and it carries oxygen to every part of this organism and allows the octopus to live in both extreme temperature conditions, like extremely hot or extremely cold.
Wow, so I knew that the iron in our blood was what turned it red, but you're telling me that it's copper in these marine animals that turn their blood blue. That's so interesting.
Right. So another question we had was, you can move on to the next slide, by the way. And one of our guests asked, what happens if you accidentally download a virus to your computer? Does it spread immediately?
Well, it depends on the virus, and most of the time, a virus is a program, so you'll have to run it for it to be effective and start working. But most viruses they're specially programmed so that they start running themselves whenever they're downloaded. So even though you'll probably be safe if you don't run a program that you don't trust, you still shouldn't be connecting a USB drive that you don't know where it came from, or you shouldn't be sending a suspicious looking email to other people.
And you shouldn't open suspicious emails as well. So
Yes.
it's like the same with people, I guess. I mean, how viruses spread between organisms to organisms.
Yeah, you need contact between the two organisms for the virus to be shared. So what will happen if the computer is infected, for example, is a smart thing to do is cut off all connection, disconnect it from the internet, turn off Bluetooth, everything, so that it doesn't have the chance to share it and infect other people that are in the same network, etc. Um, a fun fact, one of the most popular types of viruses is what's called a Trojan horse, and it's actually taken, yes, it's actually taken from the old myth. During the War of Troy, the Greeks built this massive horse and they filled it with their own soldiers. And they told the Trojans that the horse was actually a gift from the gods, and they let the horse in the city. And during the night, the soldiers left the horse and burned the whole city down and killed everybody in there. So a Trojan horse is sort of similar to that. It pretends to be a program that's actually good for you, but it turns out it's actually a virus. So you assume that it's a game or something else that's helpful. You download it, you run it, and then it does its bad stuff in the background.
So you should be careful and double check if it's a virus or not. I mean,
Exactly.
that horse should be a massive one, but I guess viruses and computers are a little bit more tinier than this, since they're all strings of ones and zeros. But there is another question before we start the coding session about tiny bugs here in your computer. So I have another question for you, but why are errors
Yes.
in a software codes are called bugs?
Um, I think this comes from the first instance where they encountered a program that suffered an error. They were trying to run a program and the computer was not working. And then when they opened the computer, they realized that there was actually a bug inside the computer. There was a moth that went inside, and that short circuited the computer, so it prevented it from working properly. So they
I guess we
extracted it.
have a picture of it.
Yes, so this, what you can see, is the first computer bug in history.
Yeah, you can see the notes below that first actual case. And I can't read this out loud. Oh,
Let's see.
thank you. So at the end, it says close down.
Yes. So even though most bugs today aren't actual bugs, the first one was an actual bug. And now we can maybe do some of our own coding and programming so that we can maybe see some codes that don't have bugs. So let me share my screen.
So go ahead, Baham.
So today we'll be focusing on two different aspects of programming that we haven't really touched on before. We may have hinted at them, but we haven't really discussed them in depth. So we will be using loops and functions in today's program. Um, loops and functions. So what do you think a loop is, Ikin?
Loop is something that goes on and on and on and on and on and forever.
Exactly. So if we want something to be done repeatedly, then we will use what we call loops. So if we go down here under control, we see these two blocks. So these are our loops, and these are quite different than each other in a very fundamental aspect. One of them is, as you just said, an infinite loop. It goes on forever and ever, whereas the other one is repeated for a certain number of times, and then it stops. So let's try the infinite loop. Let's get rid of this. So for example, let's have this sprite here move left and right repeatedly, okay?
The forever block seems way different than others. I mean, I guess you can't choose another block after that.
Yes, so since it's an infinite loop, it just keeps on going and going infinitely. So therefore, we don't really have anything that we can put after that because this is just going to keep on running.
No,
So
I see.
So we'll move to the right, wait a second, and then move to the left, and then wait a second, and this is going to keep on going. Let's, for example, see what this code does without the loop, okay? Well, maybe we can increase the number of steps to make it a bit more easy to see.
Yeah.
So now we see our friend moving back and forth. He only does this once. Make it even larger. Yes. Okay.
Yeah.
And then let's put the loop around this and see what happens.
So it goes on and on, I mean, back and forth all the time.
Yes, it repeats itself. So instead of having to write the same code an infinite number of times, we can just do something like this. But what if we don't want to maybe have it move like this infinitely, but we only want it to move a couple times? Then we can choose this block instead. So let's get rid of this and put this in there. And let's have it repeat 3 times.
1 and 2 and 3.
And that was the third one. Now it's over and we can put something else afterwards. So after doing this, for example, it can talk. So let's maybe build a program so that this sprite dances, okay?
All right. So either way, I guess I asked you this question on Tuesday, but
Yes.
and then you said let's just wait and see how it turns out. So my question was, the if block was only repeating itself.
Yes.
But can we choose differently with using repeat blocks or the forever block?
Yes, that's a really nice idea. So what we can do is maybe something like the forever block that surrounds the if block. So then we can get these two maybe move blocks to control the sprite. So if the right arrow is being pressed, then it'll move towards the right, okay? So without the loop, just a reminder, it doesn't do anything if I don't have the right arrow pressed as I press the green button. I have to keep holding down the green button when I press. I have to keep holding down the right arrow when I press the green flag. But if I put a loop around this, then it actually checks for this constantly. So the program is currently running. I'm not pressing anything. When I press the right arrow, it moves. I can still press it again and again and again until it disappears off the screen.
Now I see.
So with this, we can actually control the sprite as we wish. So we
Yeah,
can.
so it's like a game for us to, explore.
Yes, Yes, so we can have it move back and forward if we do something like this. So now let's rerun this. So when I press the right arrow or the left arrow, it moves in that direction.
Let's have the sprite move up and down.
And to do that, then we will actually, so the move block that we have right now only moves it back and forth in the horizontal axis. If we want to move it vertically, then we have to specify the position in the y coordinate, but that's going to get a bit complicated. So let's not do that right now. So maybe we can go back to the idea where we have our friend dance around a stage. Let's maybe pick a backdrop for that. So let's see.
Can we also change the costume?
Yes, so let's pick this one as a backdrop, and then we'll maybe draw something that will make him look like he's dancing. Like this, 25 maybe. So we have.
Wow, these are some crazy dance moves, Paul.
Yeah, so this is gonna be like the octopus that we talked about.
Yeah. Or a spider in that case.
Yeah. So we want him to move back and forward on the screen, but we don't want him to do this like a constant number of times, right? We want him to do this maybe a bit more randomly.
Yeah.
So first of all, we will get our loop. We'll see why we're going to use this. And then we're going to use this. This block is going to give us a random number between the two values that we pick. And this can be any number as long as we set the intervals correctly. So let's maybe pick between 10 and 50. Okay. And then we will get our move block. Where is it?
Spider will have the music, right?
We don't have any music right now, but you can maybe add some sounds of your own and then work with them. So if we do this, and then let's get a second one of these. Add a wait block after each one, and then get another random, where we'll pick between random 50, negative 50, and negative 10. Let's see what happens. So he's currently moving back and forward in a really random way, right?
Yeah.
Sometimes he moves a lot, sometimes he moves a little. So there's really nice randomness to it that makes it really dynamic.
But how we can also choose, repeats. We can also use the repeat block with pick random block as well, right? So instead of repeat 10 times, you could always use the repeats, random.
Exactly. So maybe we'll pick a number between 4 and 8. So instead of doing this a set number of times, maybe it'll do it 4 times, maybe it'll do it 8 times. And therefore we can do something like this. Let's see what else is going on.
Can we also add another object like confetti buttons or so?
Well, what else would you like to add?
It could be a spotlight or a confetti.
Yes, we can add new costumes and then program them to act in an interesting way.
So right now you're programming the characters, right?
Yes, I am programming this sprite. So if we add more sprites, then we can program each one of them separately to act in the same way. So something else that I'm going to show you is actually going to be using the variables that we learned about yesterday. So now we pick a random number each time when we're going back and forward, but there's a little problem with this, and the character doesn't stay in the middle. Sometimes it sort of shifts to the left and sort of stays there, or it might shift to the right and stay there. So there's a risk that he might go off screen. So what we can do, maybe, is actually use a variable to do this for us. So we will pick a random number that we will set as our variable each time we are repeating this loop. So we will fix a number between 10 and 50 so that it'll move that many steps. And then to get the negative version of that number, we will use something like this. So we can take the absolute value of that to get the positive number.
What's an absolute value?
An absolute value is basically the distance between that number and 0. So if we're talking about -5, the absolute value of -5 is 5. The absolute value of 5 is also 5. So we'll pick a negative number, and then we'll get the positive version of that and move that many steps. We'll wait and then move in the opposite direction, the same amount. So even though the amount that our character moves will change in each repetition of this program, it'll still be the same distance that he goes back and forward, so that he'll always be fixed in the middle. So let's center him and see how it goes. So he always comes back to the center if we do this. And that's because the distance that it moves is always constant, even though it may change between the repetitions. So we have this block of code that we are using right now, but sometimes we need to use similar blocks in different cases, right? Like yesterday when we were doing a trivia contest, we had the same block of code that we had to repeat again and again and again. And that was really complicated, that was really messy. So what we can do is use something called functions. So
Functions.
Yes.
Like the math ones?
Well, it is similar to that. So let's call this one dance and add maybe, let's add 4 input boxes, okay? So we'll first define what this is. So, well, we first need to maybe name these. So let's call this let's call these A, B, C, and D, right?
Okay.
To make it easier for us.
You're going to define what the dance function does, right?
Yes. So we will define what this dance function means. Therefore, we can use that in our code. So we will define this to be our dance function, but we'll, instead of representing these numbers by 4, 8, -50, and -10, maybe we can pick A, B, C, and D so that we can change how much we want to move every time, okay?
Okay.
Now we need to add this here. So this will be A. But here is the part where you have to be careful. So we can't just say that that's going to be A, because we need to put a number here. So what we will end up doing is actually we will make a new. I'm sorry. Wait. One moment, please. I'm having a tiny problem with my internet connection.
So Bob's trying to make sense of these letters A, B, C, and D. And while he's doing that, let's let me just give you a recap of what we have done so far. So we started with inputs and outputs, and then moved on to the conditional. And yesterday we made our own trivia quiz with these condition statements. And now Baha is showing us how to make our own function, as well as how to define it, so that we can make our strike ends.
Yes, so I fixed my problem with the infinite function. So we can't really write B or C here. These have to be numbers. So what we need to do is actually just click on these and drag them down. So now we can use these as our inputs, and then we can add any numbers we want here so that we can get that. For example,
they're like variables, right?
yes, these are variables that we will define every time we run this code. So let's, for example, have our friend repeat between 1 and 5 times a movement between -50 and, well, let's have him move a lot first, the -100 and -50, and then we'll do a second one where this will be only 1 to 3 times, and then he'll move a tiny amount between -20 and -10. Let's see. So as you can see, he's moving a lot right now, and then he's moving a tiny amount afterwards.
So instead of coding it again, like copying and pasting it all the time like we did yesterday, you're now just rearranging, reassigning numbers to these variables.
Yes, exactly. Or something else that we can do is maybe even simplify this code. So we can get rid of these, actually. And we will define dance to be this following code. So if I do something like this, then maybe we'll have our friend move to the left first. And then he'll move to the right. But since there's some randomness, he may not always be going back and forth. So this is something that you can do. You can even put this inside a loop. For example, let's do that. So first he moves towards the left a random amount of times, and then he moves to the right, to the left, and then to the right. So the randomness sometimes does.
He just left the stage.
Yeah, okay. And that's because the movement towards the left can be repeated more times than the movement to the right. So we can maybe decrease this, and then this will cause it to most likely move towards the right in the longer run. There is still some randomness to this, so there's a certain probability that it can still keep on moving to the right or keep on moving to the left.
Yeah.
But you can tweak this so that it does more or less what you want. The randomness really makes it more dynamic and a bit more fun. So I really like playing around with it.
What else can we use functions for instead of dancing?
So what we can do is basically write any piece of code that we want repeated as a function. For example, we could have used functions yesterday for our question box. So we could basically program a function called question, and we could use that with different questions and different answers each time. Let's actually maybe write that code. Even though we won't be doing the whole thing, we can still define that as a function. So we will have two inputs, since one of these will be the question, and then the other one will be the answer. Oops.
Yeah.
So now we have a function called question. So we will first say, well, no, we will first ask the question. So
do you have any real life examples for things we use in our functions in our daily life?
Well, functions are used in really different parts, in like really interesting parts. Functions are also used in math, where a number is taken and then a certain process is applied to it. to get a different number. Functions are basically how the process step works. We talked about input, output, storage, and process. Variables are a really simple way of understanding storage, and functions are how most input is processed. So we will ask the question and wait, and then we will add the if then else block here. So if the answer is equal to our desired answer, then we can say congratulations.
Now I see it's way more easier like than the ones we did yesterday.
Yes. And then if it's wrong, we can say incorrect. The answer is, and then we can add the answer here with the join block that we used yesterday. So if we use something like this yesterday, we could just use these question functions again and again, and then we could write different questions and different answers for this. So instead of having to copy that, we could just use blocks like this that we could add. So functions and loops are tools that are really helpful when we're doing something that involves lots of repetition. If it's a repetition of some lines of code or some blocks of code, then we can either use a loop to keep doing the same thing again and again a certain number of times or an infinite number of times, or sometimes what we can do is actually something that changes. And if we want this repeated code to change, then we can use these functions with these custom inputs. So a problem that we have with this, for example, is that sometimes our friend moves too far off the screen, right? And we want to stop that from happening. So we have another loop, and that's repeat until. What we can do with this is repeat this code until our friend maybe moves off the screen or moves too far to the left or too far to the right, okay?
So you're setting boundaries, right?
Yes, exactly. So let's, for example, see. Let's pick -50 or -200 maybe as our left boundary, and then +200 in our x-coordinate as the positive boundary. So we will repeat this code according to the x position. So we'll get 2 of these. And since we want to make sure it's less than 200 and greater than 200, we'll use the AND block with these 2 blocks inside.
We always use the absolute block you just told us, right?
Oh, that's
100, it worked.
yes, that's a simplified way of doing this. We can check if the absolute value of the x position is less than 200. These 2 green blocks that we have here are mathematically identical, so we can use either one of these. Let's maybe plop this in and then see how it goes. Let's set this to 0 to begin with, and here we go. Yes. What's this? Well, let's maybe use the other one. There might have been a problem with this. Huh. I think we have our own bug right now. Yes. So
is there moth in your computer? Be sure to check that out.
so I think that you get what the gist of this. So maybe you can try something like this at home where you can repeat something until you reach a certain amount. So let's maybe use a different example for this. Let's maybe not dance, but use a much simpler code for this. For example, let's maybe start with a variable. Let's set a variable to 0 to begin with, and then we will maybe add 1 to our value, to our variable, as long as the variable is less than 50, okay? So here we go. So the variable is currently at, I think the repeat until block might not be working as intended today. So we'll maybe check this out and report on that in tomorrow's lesson. That might be a problem with my computer or with the website, and we'll get you more about this.
So
But, but just to recap what we've done today, we looked at loops and functions that allow us to repeat certain segments of code to make our code easier to write and to prevent needless repetitions. They basically can make our life much easier. You can probably write good code without functions, but that's just going to be much, much harder to do. And it's going to be much harder for other people to read your code and understand what you've written. So maybe with that out of the way, we can look at today's experiment.
So as Baha said, functions help coders to write their program more efficiently and more effectively. So here's your challenge to do so. One of the prize experiments today we'll be sharing with you is make your own animation, music and dance, just like how Baha showed you. And the other one is solid or liquid. So right now I will try to do that. So to start with, Baha, can you see me right now?
Yes, I can.
All right, so to start with, I have a cornstarch right here, as you can see. And I also have a bottle of water. So that's the solid part of our experiment, and that's the liquid part. And now I'm going to mix those two. So let me just rearrange my table. Well, I guess this experiment is also about Newton.
Yes, it's well. What we are creating is a non-Newtonian fluid, but maybe not complicate things that much.
Okay, so here I will pour some water into it and mix it with my hands. Wow, it's a weird feeling. So it looks like a bowl of milk. And I'm going to add, as you can see, it's now liquid. So I'm going to add more starch in it. Now let's try this again. You can see that it's now all creamy. Try to mix it real well. Now, here's the fun part. So, although it looks like a liquid, once you squeeze it right in your hand, it becomes solid. There you can see the particles that are left in my hand. These are nuts. I mean, there. Although it may seem like liquid, well, it's not. And I encourage you to try that on your own. So it's like there's a force applying to my hand, and that doesn't allow me to press, like squeeze it any harder. So as Baha said, this one is called a non-Newtonian fluid, but because it's not an ideal fluid, it's like both solid and liquid at the same time. And this happens due to the fact that the chemical bonds between starch and water has.
That's great. Well, that's really nice. So in the meantime, I was actually checking my code and I realized that I had made a mistake. So it was actually working fine. There was just a bug in my code. Let's maybe go back and show that to everyone while we clean up again. So when I was first showing you this code, I was using this block where I would repeat until the variable was less than 50. Well, the variable was less than 50 to begin with. It was 0. So it was repeating until that. And since that condition was already fulfilled, then it couldn't really work. So I replaced that with a greater than sign. So we will repeat until the variable is greater than 0. And in order to see what's happening a bit more clearly, we'll wait a second between each increase. So now when I run the code, the variable actually increases by 1. And this will repeat until it reaches 50. Maybe we'll try with a smaller number to see what happens. So this is repeated until the variable is greater than 5. So when it reaches 6, since it's greater than 5, it stops working. So that should be something that you keep in your mind when you're writing a program like this, Atom. And I was using the greater sign in the wrong direction, which was preventing my code from working properly. So yes, I can. We're back here.
So I added more starch for you to see it. Now I'll try my best to grab a handful of this. Okay, so now that my hand is full, and you could see that it's actually a solid, but it turns out that it's also liquid at the same time. So go try that at home and let us know what your experiments, how your experiment turns out.
Great. And after that, be sure to record this experiment as a video and share it online at Twing.
Goodbye, everyone.
Bye. That's it for today. See you tomorrow.